There are various mechanisms that can serve to delay the ability of an allele to increase towards fixation within an environment. These can be a consequence of simply genetic drift, where even a beneficial allele, if it's insufficiently beneficial or if the population size is small enough, is not going to be able to increase its number with high assurance, because random effects are potentially fighting against that increase in frequency. It's also possible to have clonal interference, where you have more than one beneficial allele within a clonal population, and they're competing against each other, so that neither of them is able to rise towards fixation. With periodic selection, it's possible for one allele to increase in frequency within the population to fixation, leaving behind other beneficial alleles in the population that happen to be found in different genotypes. It's also possible to think in terms of clonal interference as leading to essentially stable polymorphisms within populations. Often, if a population in fact displays polymorphisms, that can be considered to be a good thing, because the population is therefore displaying greater amounts of genetic variation. So clonal interference, small differences in fitness between genotypes, genetic drift, these can have the effect of making it less efficient for an allele or genotype to reach fixation within a population, but alternatively, mechanisms that exist that in fact delay fixation of genotypes within populations also have the effect of delaying losses of genetic variation within the population, and ultimately, especially given environmental changes, genetic variation, that is polymorphisms, can be quite important to the fitness of a population.